number 3, it's asking us to evaluate what does it mean to evaluate? Alex, please be quiet. What does it mean to evaluate? Kind of. It kind of means to solve. Yes, but what do we have to do when we evaluate? Put the number into x. And you need to use parentheses because if you don't, you're going to get the wrong answer. So you could have put this all in your calculator all at once. I'm not going to, but you could have. You should have gotten 3. Remember that you can do this on your calculator. Like if you put this part into y equals and go into your table, you can look for where x is -3 and find y. I am going to say for number 5, start at the point it goes through and use your slope. Pass up your answer sheets. Alright, for number 1, the answer was x is 0. Number 2, you should have gotten 2 answers. X is -4/3 and x is 2. Or you could have used the decimal instead of the fraction. If I'm talking, I shouldn't hear your voice. Number 3 was -6 and 2/5, or you could have used the decimal, 0.4. Now, I didn't show you guys this, but I will once we actually do this unit. This is an app on your calculator that will also help you solve these, but we'll get to that later. I also put on here how you would actually solve this, but again, we haven't gotten to this unit yet, so we will go over that later. For number 4, it said describe the solution. So these should have been no solution, one solution, and state that solution. Infinitely many solutions, it should have been one of those things. So no solution for 4, one solution for 5, and that one solution was x equals 0. Number 6 and 7 were both infinitely many solutions. Number 8 was x equals 0. I'm sorry, it said what describes, so it should have been one solution, x equals 0. Oh, it was multiple choice. So C, sorry. I still did all of these in Desmos, so 9, the answer was D. And 10, the answer was -12.5. Before we keep going, do we need to see any of these worked out in Desmos? Can you do number 9? Number 9, yes, I can. Alright, so for number 9, usually when we solve this one by hand, Chris, put your phone up. When we solve this one by hand, we cross multiply, set both sides equal to 0, and then solve. When you put it in Desmos, you don't necessarily need to do that. Put one side of the equation in and then put the other side in. So if I put in one side, it gives me this graph. I'm going to make this a little thicker so we can see it. And then put in the other side of your equation. And it gives you the other graph. And you're looking for where do they intersect. But because our variable was x, we need to look for the x coordinate, which is 7. And you can do that for all of those. Any other questions on 1 through 10? I know I had the answer to 16 up after the test last class, but just in case you did not see it. Some of these we've talked about, but maybe not in this vocab. So property of equality just means what you do to one side, you do to the other. Additive inverse means whatever you are adding together, when you add two inverses together, they become 0. Additive identity means if you're adding something to 0, it's just itself. Multiplicative inverse is if you multiply two inverses, they become 1. So that's why I gave you that information. $17 was C because you added on both sides. For 4C, 18, you should have got 2A all over A minus B equals H. Remember, in this case, you're not really solving for something. You're just getting whatever by itself. For 19, you should have gotten A equals Q over 3 plus 5C. 20A was either one of these, S minus 2B all over P, or S over P minus 2B over P. And then 20B was either one of these, S minus HP over 2, or S over 2 minus HP. If we have questions on these 4, we'll go over those when we get back. You guys can grab your phones. When we get back, I need to see more phones in these pockets. So in order to do these, we need to know some of these facts. Do we know what the square root of 4 is? 2. So when we get to some of these other ones, think about what are two numbers that multiplied to themselves gives you 4. 2 times 2 gives you 4. So we know this equals 2. The square root of 16, 4. 4 times 4 is 16. 25, 5. 5 times 5 is 25. We're about 81. 9. Now, the same way we do square roots is the same way we do cube roots. You're thinking about what number times itself 3 times would be 27. 3. So 3 3 times 3 is 9. 3 times 9 is 3.
Why are you doing
27? Yes, sorry. That's what I meant to say.
Why are you doing
times
3?
So Chris said 3. I was just showing how that works. 3 times 3 is 9. 9 times 3 is 27. So
Wouldn't
it has
it be
to
9?
No. So in this case, it has to be the same number 3 times. What would the cube root of 64 be? It is 4. 4 times 4 is 16. 16 times 4 is 64. What about 8? 2. Because 2 times 2 times 2 is 8. So some of these you will be able to figure out, like I'm sorry, that was cube root. Some of these you will be able to figure out because it'll be like the square root of something that's a perfect square. I put your notes in your screen, Avery. And your new seat is over here. But some of these you won't. So like, if you have your calculator, put in the square root of 8. You can sit there for today. Your actual seat is right there, but that's not. What do you get? So a bunch of decimals. We don't want those decimals. So when we are simplifying radicals or square roots and cube roots, we are trying to do so in a way that we don't have square roots. So in order to do this, we need to think about factors of 8. So give me 2 numbers that when multiplied gives you 8. 2 and 4. And we're going to keep doing this until we get prime numbers. So that's numbers that multiplied, numbers that their factors are 1 and itself. So 2 is a prime number because its factors are 2 and 1. What are some factors of 4? 2 and 2. And now we've gotten to prime numbers. When we are simplifying our radicals, we're looking for a pair. If this is square root. So for square roots, we're looking for a pair of numbers. Wherever or whichever pair you want. Doesn't really matter which 2 2's you take. Every time you can circle a pair, that pair gets to come out. Think about this like jail. You can get out of jail in pairs. If you don't have a friend to get out with, you're stuck. If you have a pair, you can get out. So what that means is, since I have one pair here, I can bring that outside of the square root. Anything that does not have a pair gets left inside. So we are simplifying these in a way that all of our pairs come out, and anything that doesn't have a pair stays in. Yes?
Okay, so let's say like that 2 in that situation, box 2 is like 3. Would it be like 3 is 3 then 2?
If it was a pair of 3s, yes. We're going to do some more. Yes, Jeff.
What do you do if there's multiple factors?
We are going to go over how to do that for the next 2. Before we do that, though, put 2 times the square root of 2 in your calculator. Did you get the same thing? Yes. So that's how you know that you simplified it correctly if you get the same decimal. Notice that we didn't actually use our calculator to solve this. It's just a way to check yourself. Lisa, you said you had a question. Yeah.
X squared.
Yes. Okay. Give me 2 factors of 18. 9 and 2. But there are others, so we're going to do this 2 different ways. Can we factor either one of these numbers again?
Yes.
Which one? 9. So what and what? Do we have a pair?
Yes.
Yes, that pair gets to come out. Anything left stays inside.
Oh. Okay.
Now, what are 2 other factors of 18?
6 and 3.
6 and 3. Can you break either one of these numbers down? 6 to what and what? 3 and 2. We still have a pair of 3s even though they're separate. You're looking for pairs. As long as you have a pair, that pair can come out. Doesn't really matter where they are.
What if there are multiple pairs?
There will be some like that. So, I can't remember if this one will do that or not. Let's do 32. We'll come back to this. Give me 2 factors of 32. 1 and 4. 8 and 4. When you do this, this may be different for you or the person next to you, especially when there's multiple numbers or multiple factors, like 32 is 4 and 8. I just lost all the other factors. 16 and 2. Can you break down either one of these numbers? Yes. 4 and 8. How would you break down 8? 2 and 4. How would you break down 4? 2 and 2. Can you break down any of these numbers? 4 to what? 2 and 2. In this case, we have 2 pairs. That means they both come out. And there's 1 left inside. When we do that, everything here is being multiplied. So we need to multiply this, the 2 that came from this pair, the 2 that came from this pair, and leave 1 inside. So this is 1 pair. That's where one of the 2's came from. This is another pair, but everything's being multiplied. So our final answer is actually 4 root 2.
I thought it was a pair.
If it's a pair, it comes out.
So wait, you could do either 2 times 2 square root 2, or you could do 4.
You need to simplify it. So 4 root 2 would be your final answer.
Couldn't you do 2 squared times 2 and root?
You would need to do 2 squared to get 4, but yes.
2 times 2 is 4 still.
Yes. Andre, ask your question.
If one of the pairs is like bigger, like say it was like a 3, do you put 3 first or 2 first?
Doesn't matter, because multiplication is commutative. Order doesn't matter. You're going to end up multiplying the numbers outside no matter what. So how you put them does not matter. Let's do another one. Give me 2 factors for the square root of 20. Okay.
4 and 5.
We're doing 2 different ones, so you go ahead and try 10 and 2. I'm going to do 4 and 5. We should still get the same thing either way. Can we break down either one of these numbers? 4. 5 is a prime number. We have a pair. So our final answer would be 2 root 5. Now, I haven't been asking this for every single one, but you could go back in your calculator and check this. Do the square root of 20, do 2 times the square root of 5, you should get the same thing. Same thing for 32, you could type in the square root of 32, type in 4 times the square root of 2, you should get the same decimal. For 27, give me 2 factors. 9 and 3. Can we break down either one of these? 9 to what? 3 and 3. So even though we have 3 3's, this is a square root and we just need 1 pair. So 3 times the square root of 3 would be our final answer. So we're just breaking these down as simple as we can. Now, these didn't have numbers outside of them. I'm going to do one of these 2 different ways. Let's pretend this 2 isn't here for a second. Just focus on the square root of 8. Now we just did this, so we know the answer we should get, but let's do it again. We know we can break this down to 4 and 2. We can break the 4 down to 2 and 2. And we know we have a pair of 2's. That's going to come out. Now, I have my 2 outside already, and I'm going to put another 2 there. So you have to multiply. Yes, Kayla. So you would bring this pair out, one of the 2's out, and multiply it to the 2 that was already there.
For the 20 up top, how does the 5 get to the square root?
So, does it have a pair? No. No. Anything that doesn't have a pair is automatically inside the square root. Okay. The other way you could go about doing this, now this won't happen often, but we just did these, so we already had the answer. We know the square root of 8 is this. So we could substitute or replace that with this. And it would be the same thing. You would still be multiplying 2 and 2. And leaving anything inside the square root inside the square root. You're not multiplying anything outside to anything inside. Those are 2 separate things right now. Anyway. Let's do another one of these examples, and then I'll let you try some. We did the square root of 18 already, so I know that that is this answer, 3 times the square root of 2. So I can bring that down. But if we didn't know that, you could go back and do the square root of 18 again. What would this final answer be?
15 times square root of 2.
I want you to do these 3, either by taking what we have and multiplying it, or simplify the radical again, and then multiply it at the end. Either one is fine. Yes.
Wait, how do you get 5 times 3 to the square root of 2? How did you do that again?
Multiply 5 and 3. This is the same thing as the square root of 18. That's fine. I'm just going to go ahead and put the answers up here. Always, if you're not sure, check it. Put in the original, put in the final answer. Did you get the same decimal? If you did not, something's wrong. Yes.
So, like, if you have to write the answer out, like, on like, a test or something, like, would you have to put, like, it says 5 and then parentheses 3 and the square root of 2? Would you have to put that in the answer?
Yes. Just show your work. Okay. Before we get into these, yes.
So how are you getting 6 to 5 and with the root 20? With the root 31? How'd you get 6 and 5?
Multiply 6 and 3 and 2. Before we get into the variable ones, I just want to show you another way to do this. and then you choose whichever method you want. So we're going to write out or list out the perfect squares up to 100. So that's 1 squared, 2 squared, 3 squared, and keep going. I want you to tell me what those are. So 1 squared is 1, 2 squared is 4, 3 squared, 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. Okay. The other way you can go about doing this requires a little bit more work, is to use your perfect squares and see is whatever number is underneath the radical, is one of these a factor of this? Now, we have already done this and we know these factors already, but it's just going to look a little different. So for 8, we know 2 and 4 are factors of 8. We know 4 is a perfect square, and the square root of 4 is what? 2. So if we know that 4 is a perfect square, I'm going to call that PS right now. If 4 is a perfect square, we know the square root of that number. We can say whatever the square root of the perfect square is will come outside. And you could keep doing that. Depending on the factors you choose here, you want one of them to be a perfect square. So if I use 9 and 2, I know 9 is a perfect square. This is listed up here. The square root of 9 is 3. So that square root would come outside, and then the other factor I used would be inside. Notice that these are the same answers that we're getting. It's just a different way to think about it. For 20, we know 4 again is a perfect square. So the square root of my perfect square would come out, and my other factor would stay inside. I'm not going to do every single one of these. I'm just going to do the last two so you see that this always works. For 27, we could use 9 again. 9 is a perfect square. The square root of 9 is 3. So that would come out, and that factor would stay in. Now for 32, you have different options because 4 is a perfect square, but that means you would need to simplify 8. So when you have something that has multiple, try to think of your highest perfect square. So 4 definitely works, but 16 also works. And 16 is higher than 4. The square root of 16 is what? 4. So if I said 16 is my perfect square, the square root of 16 is 4, the other factor would go inside. So if you like that method, you could definitely use it. Otherwise, keep doing your factor tree is what we're going to call that. But you will have some examples that you don't have numbers at all. So with this, let's first go back to our factor tree, because I'm going to, again, show you 2 different ways to do these. X squared, how would I write that expanded? X times X. Do we have a pair? Yes. So that means that pair gets to come out and there's nothing left inside. So the answer to this is just X. Square roots and squares also undo each other. They're inverses, so that also makes sense. we're going to do a couple of these. X to the fourth, how would I expand that? Do we have any pairs? Yes. How many? 2. So that means outside we have x times x with nothing inside. So our answer would be x squared. So this is also being very good with your exponent rules. You need to remember if we're multiplying like bases, we're adding our exponents. What about x to the third? How would I expand that? Do we have a pair? Yes. How many? 1. So that means that pair gets to come out and there's 1 left inside. I want you to do x to the fifth. And then we'll come back and talk about the others.
X squared 5x.
The square root of what?
Wait, wouldn't x squared be the inside the square root of?
So let's see. How many pairs do we have?
2.
2. That means both pairs get to come out and there's 1 left inside. So it would be x squared times the square root of x. Now, I said I was going to show you another way to do this. So you can definitely still do this. There is a trick to this that if you remember this trick, it will always work. Think about this as division a little bit. This is a square root. You can draw 2 outside if you want. 2 goes into 2 how many times? Once. With none left over. If this is a square root, 2 goes into 4 how many times? Twice. With none left over. This is a square root, 2 goes into 3 how many times? Once. With 1 left over. So you could do that with your variables only, not with your numbers. And the same thing here. This is 2 goes into 5 twice with 1 left over. That method always works. Now for your cube root, we now need groups of 3, no longer pairs. Yes.
So on the test, are we allowed to do x times x?
You could do either method.
Because you know you have x squared, are we allowed to do that too?
You mean leave it as x times x? No, you need to simplify it. So your final answer should not be x times x or 4 times 4. It should be 16 or x squared or whatever it is. So this method still works, but we're going to do the expanding part first. X to the third we know is x times x times x. Because we now have a cube root, we're looking for groups of 3, not pairs of 2. Here we have a group of 3, so they all get to come out. I'm going to skip one. For this one, it would be x times x 5 times. I have one group of 3 in this 5. So that one group would get to come out, but the 2 other x's would stay inside.
Wait, I'm confused how you got the answer to the first one in the first place. You just do 3 x's.
So anytime you have a cube root, you're looking for a group of 3 instead of a pair.
Wait, but what about the cube inside the square root? What did you do with that?
This cube,
Yeah.
was this. X to the third is x times x times x.
But isn't that what it was outside as well?
That was the cube root of. So just like this was the square root of something squared, it's almost the same thing. Yes.
The one we just did.
Wouldn't it be like x squared on the
On the inside, I just didn't. Now, notice that this looks like it's x to the third, but it's not. It's x times the cube root of x squared. If you need to add parentheses, so you don't confuse that. But, Sophia, just like your x squared went away here, there was nothing left over. There was nothing left over for that one. The rule that I was talking about when you divide still applies, but now it's different because you have 3's. 3 goes into 3 how many times? Once, with nothing left over. 3 goes into 5 how many times? Once, with how much left over? 2. So you could still do that rule. Okay, I want you to try those last two. I'm going to do this by way of expansion, but if you did it this way, that's fine too. So the answer to this one should be x to the third. 3 roots came out. And when you multiply those 3, you get x to the third. Or if you're doing the other way, 3 goes into 9 3 times with nothing left over. For this one, two groups are going to come out, leaving one inside the cube root. So your final answer would be x squared times the cube root of x, and you can put that in parentheses if you would like. You don't need to, it's not necessary. Okay. Any questions on these so far? Flip over to the back. Now, these questions have both the variables and the numbers. So we're going to be combining both of those methods, using the numbers and using the variables. Okay. So when you do this, depending on which way you're using the numbers, either dividing until you get a perfect square. What's that? Oh, you need that right now. Please wait. We can have a seat actually. So whether you're using the method where you use the factor tree, or you're using the method where you find factors and divide by the perfect square, either one is fine. I'm going to go ahead and use your factor tree. 2 factors, you could use 10 and 2 or 4 and 5, doesn't matter. And I know I need to break 4 down again. At the same time, I'm going to expand my variables. I know x squared is x times x. So I'm looking for any pair to come out. We have a pair of 2's, we have a pair of x's. The 5 is going to stay inside. Now with these ones, you can still check the number part. You could still put the square root of 20 in your calculator and 2 times the square root of 5, but the variables you won't be able to check on your calculator. Let's do another one of these. For 32. Now, I'm not going to use the factor tree for this one. I'm going to go back and do the other method, but if you're using the factor tree, that's okay. I know 16 and 2 are factors of 32.
Wait, how'd you get a pair of 2 on the first one, 2x?
4 and 4. Or 2 times 2 is 4.
Yeah, but that's only one pair.
This is a pair of 2's.
Yeah, wouldn't that be then just 1x? Or just one
You
outside?
have a pair of x's and a pair of 2's. 1, 2 comes out, 1 x comes out. You're multiplying 2 and x together.
My head hurts.
So I know 16 times 2 works. I know 16 is a perfect square. The square root of 16 is what? 4. So I know 4 is going to be on the outside. 2 is going to be on the inside. I don't know about my x's yet. I still need to do that part. So this is the second method on how to do this. I know I can look at this as 2 goes into 3 once with 1 left over. So there are different ways you could go about simplifying this. It depends on which methods you like best. I would also rewatch this video on Emoto so that you understand each method. If you were to break it down, you would end up with a pair of 4's, a pair of x's, and then 1, 2, and 1 x by itself. I want you to try these two however you want to simplify those. And then we'll... I'm just going to use the factor tree method. If you did not use that method and would like to see the other, I can do that. You would just need to let me know. So with this one, our factors are 2 and 4. We can separate x to the 4. You need to break down 4 again to 2 and 2. Here you end up with a pair of 2's. Go ahead, Alex. And then 2 pairs of x's. So each of those come out. And you're left with the 2 inside. Anything that is like terms or are like terms, you need to combine. Or like bases, you need to combine. So 2x squared times the square root of 2 is your answer, your final answer for this one. And if you look back to the square root of 8, the one we did on the front, we had 2 square root of 2, so we at least know that that part is correct. If you look back to when we had the square root of x to the 4th, we know that was x squared, so we know that part was right. So if you look at different pieces, you should be able to see whether or not you did that right or not. What were 2 factors we used for 54? Okay, so I heard 27 and 2. You could have used 9 and 6 as well. One just has more simplifying than the other. Seven would be broken down to what and what? 9 and 3. And then 9 to 3 and 3. Right? So we have a pair of 3's, a pair of x's, another pair of x's. All of those get to come out. Inside, you're left with a 3, a 2, and an x. And you need to multiply these together. So 3x squared times the square root of 6x. Do we have questions on either of those two? Or if you did it the other way, do you need to see that? For these bottom ones, we now need groups of 3. So cube root, group of 3. Keep that in your mind. We are no longer looking at pairs, just for these. But notice that these are back to square root, so pay attention to what the number root is. For this, give me 2 factors of 16. 4 and 4. Again, break these down as much as you can. So 2 and 2, and 2 and 2. I can break down x to the third, x times x times x. But we're looking for groups of 3. So we have one group of 3 with our 2's. We have a group of 3 with our x's. That would come out. 2x. Inside, we would just have that 2, but these are cube roots, so this needs to stay a cube root. If you don't put the cube root, it's now a square root, and you change the problem. So don't do that. If you want to put parentheses, you may. You don't need to. Let's do one more of these. For this one, give me 2 factors of 54. 9 and 6. No, we have to break those down even further. 3 and 3. 3 and 2. And then x to the 5th is x times x 5 times. Again, we're looking for groups of 3. So with our 3's, we have a group of 3. In our x's, we have one group of 3. And then anything else gets left inside. So the 3 comes out, the x comes out. Inside, we have 2 times x times x. But this is a cube root, so it needs to stay a cube root. And we need to multiply these two. Notice that the answer we got here and the answer we got here are different because one was a square and one was a cube. Different things came out and was left inside. Do we have any questions on these types? I want you to go ahead and try these two, and then I'm going to show you the same way we did the perfect squares method. I'm going to show you that method for these. Check your answers once you're done. So in this case, you end up with one group of 2's, 3 groups of x's, with a 3 and a 2 left inside. So 2x squared times the cube root of 6.
So would it be there's 3
Yeah, I
X's.
don't know why I put. I just missed one. That's what it was. There we go.
There you go.
2x to the third times the cube root of 6. What were two factors we found for 128?
16 times 8. 16 times 8.
16 times 8. I was like, I heard 3 different things. You could keep breaking those down. I could do 8 and 2 or 4 and 4. Does not matter. I think this is going to work out the same. But here, I haven't broken it down completely, but I know I see a group of 4s. If you were to keep breaking it down, I believe you're still going to get the same thing. Because you end up with 2 groups of 2, or 2 groups of 3 that are 2. So you would still get that 4 on the outside. So whether you stopped here or kept going, you would get the same thing. Oh, I didn't do the x's. And you have 2 groups of x's with 1 x and 1 2 left inside. So 4x squared times the cube root of 2x. You may not have time to finish these. I want you to write these down really fast. Like at the top. Perfect cubes. So this would be 1 cube, 2 cube, keep going. I'm just going to list them out for you. 1, 8, 27, 64, 125, 216. I get foggy after that one. 343, I think, is 7. I don't remember 8. What's 8 to the third? Do that in your calculator really fast.
512.
Thank you. 729, I think, for 9, and then 1,000. So next class, I'll show you how to do it with these. You don't have homework, but if you would like to keep practicing, do that. If you want to do the ones in your SOL review, that's not homework, but you could.